So cool, we've got reflection and refraction. At this point, you're probably noticing that while sight and sound are both waves, they kind of aren't exactly the same thing. They do things a little bit differently. And that's actually true. If that was your intuition, that's exactly right. There's a slight difference in how these waves work, and even in what these waves actually are. Now, light goes exactly how we've been describing it up at this point. If I got a slinky, it's kind of as if there's molecules. Each little ring loop in the slinky is its own molecule, and the molecules just kind of wave up and down, and we can send waves across time and space by making these molecules vibrate in unison. And that's kind of this up and down motion. It's kind of like sine of x. It goes up and down if you're into math and that sort of thing. This is what's called a transversal wave. We transverse space and time with it. Now, think of another great example of this is the surface of a pond. You know how a surface of a pond goes up and down and up and down. When you drop a rock into it, it kind of makes those ripples. It's transversing the pond. Now, a slinky can help us also see the other type of wave, and this is how sound waves work. They're called compression waves. Well, if transversal waves go up and down, a compression wave, also known as a longitudinal wave, does these kind of compression things. So it's where you have these two things together, and you can kind of send waves across just by kind of making a quick compression with the sending device. And so speakers, when they are sending waves, what they're actually doing is they're compressing waves. They're doing a little bit of a quick jerk in whatever device it is inside the speaker that's actually making the sound. It's making this quick jerk inside the speaker, which is compressing a lot of the atoms and sending the atoms across time and space. Some atoms are bumping into other atoms, and those atoms are bumping even more atoms, and those atoms are bumping into more atoms, until all the way it gets to the source, which is your ear. So it kind of compresses and sends these compressions all the way over to your ear. That's how a compression wave works. It's also called a longitudinal wave if you see it in other places. Longitude, you might remember from geography, is like the left and right planes of Earth. There's latitude up and down, and longitude left and right, longitudinal lines and latitude lines. And so you can kind of think of it as shock waves going through the left and right, as moving left and right through. If transversal waves go up and down, longitudinal go left and right from compressions. So while your speakers are technically making waves, they're really just oscillating back and forth at this really at this really nice pace, so you can hear the soothing sound of my voice all day long. Okay, let's go ahead and summarize quickly everything that all the major points we've talked about with waves so far, with this cool video by Nerdfighter that I really like.